video, I'm going to drop some of my random thoughts on why I feel math is beautiful. Okay, so first of all, let's go into matrix. We have defined that one in the following way: 1001, and this definition is because numbers a into 1 equals to a. Yeah. In similarly, in a matrix, if there are some matrix, let's say 2, 3, 5, 7. So for this matrix to give itself, 1, 0, 0, 1 does the work. So that's why we defined this matrix as 1. Yeah. So this is how we made definitions about. So this is said to be 1. In the similar way, minus 1 would be just to multiply everything by minus 1. Minus 1, 0, 0, minus 1. Now, uh, in numbers, like 1 square would be just to multiply itself twice, yeah. Yeah. And that gives us itself. If we multiply, it gives us same thing, and that's 1 square. Similarly, uh, if there's a function like this, let's say 1 minus 1, sorry, let's say 0, 1, 0. If you multiply this matrix with itself, what you get is 0 minus 1, 1, 0, 0 minus 1, 1, 0. So basically, first of all, there is 0 times minus 1, that's minus 1. And then we have 0 times 0, 0 times 0, minus 1 times 0, minus 1 plus 0. Yeah. So this is actually minus 1. Yeah. And the square of this matrix is minus 1. So this matrix can be told as I. Yeah, this matrix can be called as I. So this is our, okay, so this matrix is square, actually not this matrix. The square of this matrix is minus 1. Yeah. So I is this one, 0, minus 1, 1, 0. So this is I matrix. We just find out from the experimentation because it was satisfying the properties that we had put for I, that is it should be square root of minus 1, and the matrix equivalent for minus 1 is this matrix. So this is I. Now we have I. Now if I try to find out I times pi, that will just be 0 minus pi times 0. Yeah. Now in numbers, e to the power I pi is just minus 1. Yeah. Now because we are making like similar definitions for matrix, e to the power I pi should be minus 1. Yeah. In minus 1 is, we know what is it? It's just minus 1, 0, 0, minus 1. That means e to the power 0 minus pi 0 should be equals to minus 1, 0, 0, minus 1. So if we just like go with the equivalence of numbers to the matrix, we get this result. Now till now we might not have like what it means to raise a matrix in the power. We don't have such things, but this seems to be a correct statement. And if we just like try to evaluate this by using some definitions of e, let's say we have one definition of e to the power x as 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Yeah. So now if we try to use this definition to evaluate this thing, because we can obviously find the powers from matrix, just multiply it twice, multiply it thrice, and divide by a constant. That can also be done. And if we just input x as this matrix, we actually get minus 1, 0, 0, minus 1. So you see, the infinite series sums to this matrix. So like maths is never wrong. Like you might get this result in an easier way, but this one is completely absurd thing that we don't know like what this result will be. But through some like equivalence and connections, we have found the result. And now when we actually plug in, we get the same value. And that's what makes math beautiful. Like any way you go, like if it's supposed to be true, it will definitely be true. Doesn't matter like what approach you make or like what kind of manipulations you make, the correct thing will always be correct no matter how we approach it. And that's what the most fascinating thing about maths for me. Yeah, I actually tried the first, this one is 1001, and like adding 0 minus pi pi 0, and then uh, 1 by 2 of the square of this matrix, so you can multiply it twice. Yeah, 0 minus pi. I did multiply, and like I did up to few terms. I actually did up to few terms, so 1 by 6. So we can multiply it thrice. That's not that hard. It's somehow hard. Yeah. So you can try this. This is actually doable, and you actually get the same result. And that really fascinated me because the exponenting by a matrix was something like unthinkable. But yeah, there was some one way, and when I did try that, it actually worked. So this like give me idea that if something seems to be true, if we are doing correct approach, if we are making correct approach, then no matter how we do, the correct thing will always be correct. And that completely blew my mind. I hope you also like this, and yeah, thanks for watching.